So my overall research is in wastewater-based epidemiology. And what that is, it's a tool to inform on the health status or contaminant exposure of a community. This could include looking at antimicrobial resistance, detecting and quantifying viruses in a community, and even looking at the contaminant exposure that a certain community is facing. So from 2021 to 2023, we had our COVID project. And in that project, we were collecting the wastewater from residential dorms on Fairfax campus. And we were able to not only detect the presence of SARS-CoV-2, but we were also able to quantify those results into a number of cases. And we were able to do that with the saliva COVID data from the university. So here in our fridge, we have a couple of samples from that project. We do a lot of qPCR, so we were able to collect our samples, concentrate, extract those samples for the viral RNA, and then we analyze that using our RT-qPCR, reverse transcription quantitative PCR analysis. So these are a couple of PCR plates that we have from this project. We went through hundreds of these. We use a TACMAN probe on this RT-qPCR plate, and we have our CDC approved SARS-CoV-2 primers and probe mixes that we're using. As I mentioned, I do a lot of RT-qPCR, and so this is the instrument that we use here. We load our plate into the instrumentation here, and we close it, and then we are able to let it run, and we are finding an amplification plot from this computer here. So in this sample, we're able to look at the positive N1, so that's the SARS-CoV-2 positive control, and we also have a recovery control for fecal markers and fecal indicators. So that's what we were looking at for about 2 years. We published this work in 2023. So if you're interested, look at our publication on the detection of SARS-CoV-2 in residential dormitories at George Mason University.